The following presentation is designed to describe and demo recommender systems with the NVIDIA Merlin framework. Recommender systems drive every action that we take online. When you go to an internet site on your personal phone and it shows fashion suggestions that you haven't seen before, that's a recommendation system behind the scene. Recommender systems play a critical role in driving user engagement on online platforms. A report from McKinsey attributed 35% of what consumers purchase on Amazon and 75% of what customers watch on Netflix to recommendation system algorithms. Our Merlin demo focuses on NVTabular for ETL, which means extract, translate, and load, a feature engineering and pre-processing library for tabular data. It provides a high-level abstraction to simplify code and accelerates computation on the GPU using the Rapids cuDF library. A part of the Merlin ecosystem, NVTabular works with other NVIDIA components, including Huge CTR, a training framework for click-through rate estimation, and Triton Inference Server to provide end-to-end acceleration of recommender systems on GPUs. There are multiple challenges when it comes to architecting large-scale recommender solutions. Iterating over feature combinations takes longer than training. Tabular data scales poorly. Embedding tables don't fit easily onto GPUs. The path to production is complex. To alleviate these challenges, recommender systems can take advantage of the NVIDIA A100 GPU. DGX A100 delivers 10x performance across the development pipeline. Companies can build recommender systems more quickly and economically than ever. NVIDIA GPU's parallel processing capabilities let them blast through data-intensive tasks. You can get started with the Merlin developer documentation for NVTabular, which describes the various resources available to help you innovate with A100 GPUs. The following are some resources on how you can get started with Merlin on your DGX A100 today. Visit NVTabular GitHub page at github.com/NVIDIA/NVTabular. In the README, you'll find all the installation steps, the link to documentation, and a section with tutorials in the form of Jupyter notebooks that you can run on your own hardware. You can also download and install NVTabular as a Docker container hosted on NGC. In the following Jupyter notebook, we demonstrate the steps for carrying out data preprocessing, transformation, and loading with NVTabular on the Kaggle-Rossmann dataset. In our demo, we first prepare our dataset. Let's start by defining information about our data, including its schema, what columns to use, and what sorts of variables they represent. Next, let's identify what files are available to train on in our data directory. A workflow is used to represent the chains of feature engineering and pre-processing operations performed on a dataset. We add operations to a workflow by leveraging the preprocess method for categorical and continuous variables. We frequently need to measure properties across datasets which are too large to fit into GPU memory or CPU memory at once. Now that our data is preprocessed and saved out, we can leverage datasets to read through the preprocessed Parquet files in an online fashion to train neural networks. Setting some universal hyperparameters for our model and optimizer, we choose our framework, train our model, and retrieve our results. Thank you for joining our Merlin demo highlighting NVTabular.